Hello and welcome. In this video, we are gonna talk about pretty good privacy in network security. Okay, our agenda is introduction to PGP and a brief history about PGP, algorithms, file format components, bugs and attacks, and finally the conclusion. Here we have introduction. For the introduction, we have PGP. What is PGP? PGP is a software designed to secure digital communication and files via encryption and digital signatures, safeguarding privacy and authenticity by thwarting unauthorized access and impersonation. It employs cryptographic methods encompassing conventional encryption with shared secret keys and a public key infrastructure that streamlines key management by reducing the number of keys needed. PKI additionally facilitates the creation of difficult to forge digital signatures. And here we have another topic, how PGP works. Okay, PGP combines symmetric key and public key encryption. A random session key encrypts the data using symmetric algorithm, and then the session key is encrypted with the recipient's public key using an asymmetric algorithm and sent with the encrypted message. Then the recipient decrypts the session key with their private key and then decrypts the message with the session key. So there's two steps to decrypt the message. And finally, digital signatures are created with the sender's private key and verified by the recipient using the sender's public key. Let's go to the next slide. Mathematics, the mathematic background or the concept used in PGP cryptographic foundation. The mathematical underpinnings of PGP rely on key cryptographic principles, including modular arithmetic employed in public key algorithms like RSA. Prime number theory is crucial for generating keys in algorithms such as RSA, while discrete algorithms play a fundamental role in algorithms like DSA or El-Gamal. Additionally, hash functions are utilized within PGP to maintain data integrity and facilitate the creation of digital signatures. For the key size impacts encryption strength. RSA keys typically range from 1024 to 4026 bits. Larger keys offer more security but require more processing power as well. Symmetric keys are generally 128 bits or 256 bits in order to balance in security and performance of the encryption process. For the Web of Trust is a let's explain it in detail. PGP employs a decentralized trust model known as a Web of Trust instead of centralized authority. Users sign each other's public keys, forming a network of trust relationships, and trust levels are based. Trust levels vary, and users decide whom to trust based on their criteria and the number of endorsements by the key they have received. This model provides flexibility and user autonomy in establishing trusted communications. Then we are going to the history, a brief history. PGP developed by Phil Zimmermann in 1991. and quickly gained popularity for its robust encryption capabilities, particularly among activists and privacy advocates. Despite legal challenges stemming from United States, export regulations on cryptographic software, PGP's source code was globally published, facilitating its widespread adoption. Initially distributed informally as Girlware, PGP transitioned into both commercial and open source versions, evolving with improvements in user interfaces, email client integration, and encryption algorithms as well. Now we are heading to algorithms. In algorithms, we have five step, or we can divide it into four type, better say it. First one is symmetric block ciphers. This is for encrypting data by using advanced encryption standard AES or triple DES, or data encryption standard. And second, public key algorithms. This public key used to encrypt session keys, not the message, and create digital signatures. For example, RSA. And hash functions, which is another type of algorithms that are used by PGP to secure the message while transferring it. A hash function creates message digests by using SHA-1 and SHA-256. And secret sharing algorithms distribute trust among multiple parties. Here we can talk about file format components, the component in the file of the PGP's data. The first component is a header, which includes metadata about the file, and the second, encryption session key, the encrypted with the reciprocal key. Ciphertext, the encrypted message. These are also in the file format components. And digital signature ensures message authenticity. By the way, compression reduces the size and enhances security. And radix 64 encoding. This is one of the encoding methods or types. It converts binary data into ASCII text in character sequence. Better say it. Now we can head to bugs and attacks. Actually, I've listed some common vulnerabilities. First one is passphrase weakness. Simple passphrases susceptible to attacks. It is more vulnerable. Key management is also another factor. We have to be aware about what key management software or anything we do to save our keys. Secure storage and regular updates are crucial. Algorithm vulnerabilities need for stronger update algorithms. For example, we have an algorithm, we better change it among time, not using same algorithm all the time. Implementation bugs, for example, regular updates and patches are essential to maintain your program. You have to continuously solve the bugs and find the solution of the bugs that you are faced to keep your files secure. Side channel attacks, this is another vulnerability, common vulnerabilities as well. Exploit information leakage from physical implementation. And the man-in-the-middle attacks, verify public keys through multiple channels. Replay attacks use timestamps and session identifiers, which these are unique ID, or we better say unique data. For example, timestamp, which updates each microsecond. And finally, in the conclusion, importance of vigilance, the power of using PGP. PGP provides robust encryption for digital communication, and awareness of vulnerabilities and best practices is essential to maintain your data and PGP software. Proper key management and regular updates maximize effectiveness of the program as well. And this is the end of the presentation. I hope you gained a simple knowledge in this presentation, and thank you for watching the video.